We've just done quite a bit of practice on how to solve those one-step equations. Now we're going to talk about how to solve equations that require more than one step. So when we have more than one thing going on and we have to use more than one property of equality, what we're trying to do is we're going to isolate the term with the variable first, or the way that I remember it is to start on the side that has the variable but undo the operation furthest away first. So let's take a look at this question. On the side that has the variable, it is being multiplied by 4, it is also being subtracted by 7. I have to undo both of those things. Now if I chose to divide by 4 first, look what's going to happen. I'm going to divide every single thing by 4. Now that works okay for x, but now I've got an ugly fraction and an ugly fraction, and I don't like fractions. So instead of doing it that way, in order to make things nice and pretty, I'm going to start with a minus 7. If I add 7 to undo minus 7, that simplifies the left side to just 4x. So that 4x is going to come straight down. 9 plus 7 is 16. Now this is a one-step equation, and the one-step equation is 4 times x. So now if I divide by 4, look how pretty everything is. I get x equals 4, and I didn't have to ever deal with those fractions. So it's your best bet to either remember to isolate the value that has the variable first and then isolate the variable, or like I said, start on the side that has the variable and furthest away. Same thing for my second equation here. I've got this x divided by the negative 3. Remember, I'm going to think about the negative being on the denominator. So x is being divided by negative 3. We're also adding 2, but we're adding 2 to this whole thing. So first let's isolate this whole thing by subtracting 2 from each side, because that's going to make it much simpler. So now I have x divided by negative 3 equals 5 minus 2 is 3. And now I'm going to undo the divided by negative 3 by multiplying by negative 3. And on the left side, I get x over 1, which is x. And on the right side, 3 times negative 3 is negative 9. This next question is just like the questions we just did, and the second one on this page is a little bit different. So I'm going to kind of go through this first one quickly. The side that has the variable is the right side. I will undo the plus 11 by subtracting 11 first. 14 minus 11 is 3. I bring down the negative 3x and those 11s go away. And now I'm trying to isolate x by dividing by negative 3 so that I get just 1x. And I get negative 1 equals x, or if I want to rewrite it so x comes first, x equals negative 1. Feel free to do your check. For the second one, we see that something's a little bit different. So maybe you've noticed it already and maybe you haven't. What I see is that I have an x on both sides, and that's the first question that we've done together where we have an x on both sides. So I really have two choices here. My first choice is to undo, well, basically what I'm trying to do is get all of the x's to one side. And so I can choose to add 5x, because if I have a minus 5x and a plus 5x, won't they cancel? And I would get 5x on each side. Now if I do it that way, that's great, and this is not a division sign, so don't get confused there. I'm just adding 5x to each side, which gives me 8 equals 8x minus 32. So this works great. I now have an x on only one side of the equation, and now I'm starting on the side that has the x and undoing the furthest thing away. So I'm going to add 32 to each side. That gives me 40 equals 8x, and then of course I would divide by 8 to get x equals 5. This is one perfect way to do it. Now I want to redo that question. I'm going to do it right here in the middle where I happen to have some extra room. I'm going to redo it the other way because at the very, very beginning I made a choice to move that x off of the left side by adding 5x. Now maybe I prefer to have the x on the left side. A lot of people really like that x on the left. In which case, I would try to get rid of 3x from the right side. So if I try to get rid of 3x, I would have to subtract it since it's positive. And if I do that to the left, I have to do it to the right. So before I do that, take a moment to look at what I've done. I've put the x values underneath the other x values. So I'm not trying to add it to 8 or to the 32 because those are not like terms with the 3x. Negative 5x minus 3x, I'm going to keep flip change to give me negative 8x. I bring down the plus 8 because I haven't done anything with it yet. These x's go away, but I still have negative 32. Don't forget that negative belongs to the 32. Now, before I continue, I want you to look at this line of work and this line of work. Do you see how these two, this one has a positive 8 equals 8x minus 32, and this one has a negative 8x, and the 32 is still negative. So what's going to happen now is when I'm starting on the side with the x and furthest away, and I subtract that 8, I end up with negative 8x equals negative 40, which is the exact opposite of what I had here, but what I know is when I divide by that negative, I still get an answer of positive 5. So I have chosen to do it both ways. This way was easier because I didn't have any negatives to deal with, and I got x equals 5, but x was on the wrong side. This way I had to deal with more negatives, but the x was on the proper side. So you can make that choice each time, and it really won't matter which one you do. Here are two for you to try on your own. So press pause, try both questions, then press play to see how you did. For my first question, I'm going to make a choice. I either move the 3x off of the left side or move the 1x off of the right side. The more you do this, the more you'll get used to which one you like better. I like to deal with positive values, so I'm going to choose to subtract 1x from each side, because if I know if I subtract 1x from 3x, I end up with a positive 2x, and I don't have to deal with negative values. Bring down the minus 7. 1x and minus 1x are opposites. They cancel out, and then I get 15. Now I'm going to add 7 to each side of the wall. On the left side, the minus 7 and plus 7 are opposites, so they cancel. So I bring down 2x. 15 plus 7 is 22. And now it's a one-step equation. So I'm going to get rid of the 2 times x by dividing by 2. And that gives me x equals 11. Again, on any of these questions, feel free to plug that value back in to do your check. And this last one is actually a little bit easier than the one we just did. I'm trying to get that 3x by itself. So notice that there's no x over here. What you should not do is to subtract the 50 from each side, because then you'd have 0 on the left side and that wouldn't do you any good. So what I am going to do is subtract the 5, because the 3 is already by itself. So 50 minus 5 is 45. On the right side, 5 and minus 5 cancel, and I get negative 3x, or minus 3x. Now I need to get rid of this multiplication by dividing by negative 3. And when I divide, I get negative 15 equals x. If it makes me feel better to put the x on the other side, then I can say x equals negative 15 once I've completed the entire question.